Okay, this is the third video on Chapter 2 of our college algebra course, and it deals with exponential and logarithmic functions. We covered the first lesson in this composite functions, and then the next lesson was on one-to-one and inverse functions. This lesson will cover exponential functions, and this will lead us to the next section of the next lesson, which will be on logarithmic functions. So let's look at the definition. It says an exponential function has the form f of x equal a to the x. Okay, where a is a positive real number, has to be positive, and a cannot equal to 1. And the domain of these types of functions is always going to be the set of real numbers. Now the graph of the exponential function will look like the one I have here on the left. So typically it'll have a domain which will be all real numbers. So from negative infinity to plus infinity. The range will go from 0, not including the 0, to infinity, plus infinity. And the horizontal asymptote will be the x-axis, or equation y equal 0. So typically the graph is going to approach the x-axis. It's going to come down like this, approach it, never touch, and then it's going to rise and continue on to infinity. So that's why the range is going to go from 0, not including the 0 though, because it never touches the x-axis, and then it goes on to infinity. Okay, so this is typically what your graph is going to look if the base is greater than 1. So if this a right here is 2 or 1.2 or 3 or 3.1, anything larger than 1, basically the graph is going to go this way. So it's going to be increasing. Okay, so it's going to be, this will be a one-to-one function then. Just remember, for a one-to-one function, it has to be a function. A horizontal line crosses the graph at only one point, so this satisfies that definition. So this is a one-to-one function. Now, if the base is between 0 and 1, cannot be negative, but if it's between 0 and 1, like 1/2 or 1/3 or 2/3 and so forth, then it's going to come down. It's going to pass to this point again, 0, 1, but it's going to come down. So it's going to come down this way. Okay, approach the x-axis but not touch. It'll have the same domain, minus infinity to infinity. The range will equal to, again, from 0 to infinity, not including 0, and the horizontal asymptote will be y equals 0. So that's going to be your typical exponential. Now things can change if things are added. Okay, so I want to make this statement here. If you know the graph of y equal f of x, so let's say the graph of y equal f of x is 2 to the x, which it would look like this. If you know what that looks like, then you can determine the graph of f of x plus k. In other words, adding a number or subtracting a number. Simply moves the graph up or down. Y equal minus f of x simply reflects the graph over the x-axis. Y equal f of x minus c, where c is some positive number, simply shifts the graph to the right or to the left, depending on the value of c. Okay, if c is positive, then it's going to move to the right. This becomes a plus sign here, which makes c a minus c, then it's going to move to the left. Okay, and then we're going to be using this note here that I have. If you have an exponential, a to the x is equal to a to the y, so you have the base the same, then x will equal to y. If the bases are the same and you have equality, then the exponents have to be equal. That's assuming that a is positive and a does not equal to 1. Because notice if I put 1 to the 20 and 1 to the 30, I still get 1 because 120 power is 1. But 20 does not equal to 30. So in order for this to be satisfied, a cannot be 1. Now I want to make this point clear, so I'm going to look at this right here. So let's look at this graph right here. And this is the graph of y equal 2 to the x, or f of x is equal to 2 to the x. So just to show you, I have some parameters. Basically, this is defined. If I click on this here, well, it doesn't show it to me, but it's y, or f of x, equal to a b to the x minus c plus k. So these are the parameters. So notice notice that if I increase the value of k, so if I move it, so notice over here what we have. This is 2 to the x plus 1. So if I add 1 over here, it moves the graph up 1 unit. So now instead of having a horizontal asymptote at y equals 0, you have it at y equal 1. Y equal to 1. The domain stays the same. The domain is still going to be negative infinity to infinity, but the range is going to go from 1 to infinity, not including the 1. Okay. Now let's change this parameter to a negative 1. Now notice instead of passing through 0, 1, it passes through the origin, and now the graph drops. So now the horizontal asymptote is at y equal negative 1. Domain is still the same, but the range now goes from negative 1 to infinity, not including the negative 1. Okay, let me put this back to 0, and let's see what happens if well, let me do this here. So the coefficient, let's say I make the coefficient a negative number. Okay, negative 1. Let's say the coefficient, now I have f of x equal minus 2 to the x. Notice it's reflected. It's reflected. To 1. Okay, oops, keeps changing. Okay, there you go. Oops. Okay, so I have it at 1. And now notice what happens if I change the value of c. So I'm going to move this to 1. So notice the exponent over here in the function. It's, instead of 2 to the x, it's 2 to the x minus 1. So notice how the graph shifted to the right. So instead of passing through 0, 1, it passes through 1 and 1. Okay, 1 and 1. Okay, now notice if I shift this over, let's say I make it a negative 2. So c is negative 2, so this becomes x plus 2. So notice because the c is negative, it shifts to the left. So instead of passing through here, we go 1, 2, and now it passes to this point over here. Okay? Which would be negative 2 and 1. Right, if you put a negative 2 there, you get 2 to 0 is 1. 1 times 1 is 1. So instead of passing through this point 0, 1, it passes to the point negative 2 and 1. Okay, so that's what happens when you change those parameters. Okay, so let's go back to this one now. This one says evaluate. So examples, we're going to evaluate some exponentials. So in this case, the best thing to do is just to use the calculator. So let me get my calculator, virtual calculator here. Okay, so we're going to find 3 to the 2.1 power. So this is just a calculator problem. So we enter the 3 and then exponent, and that's 2.1 power. So 3 to the 2.1 power. And we get enter. And we get the two places 10.05. 10.05. Clear. Okay, now we want e, that's your exponential, e to the negative 2.4. So we find the e over here, hit the second, and then ln. Okay, there's the e. And evaluate that at negative 2.4. Close parentheses. Get enter. There we have it. So the two places, that would be 0.09. 0.09. Let's clear this. Okay, let's look at these problems. It says, graph each of the following. Determine the domain, range, and horizontal asymptote. Okay, so here we're going to be using some of the ideas I just went over. So, okay, so for the first one, A, f of x is equal to 4 to the x. Okay, so we know what the graph of 4 to the x looks like. Okay, that's the one goes up, passes to the point 0, 1. So we're adding 2 to that, so we're going to shift it over 2 places. Okay, up 2 places. So instead of having a horizontal asymptote at y equals 0, we have it at 1 unit. So this would be 0, 2. Okay, so then this one then would pass to the point 0, 3. Notice if I put a 0 where the x is, again, for the 0 is 1, 1 and 2 is 3. So that passes through this point. And again, if the base is larger than 1, the graph is going to go up. Okay, so this graph then is going to approach the horizontal asymptote y equal to 2. So it's going to go this, pass through that point, and then it's going to go up. Okay, a little bit sloppy here, but let me try this again here. So this is the point 0, 3. So again, it goes something like that, and then it approaches. Well, let me clear it again. So it goes, okay, something like that. So it passes through this point right there, which is the point 0 and 3. And the domain is still negative infinity to infinity, so I wanted the domain, so we have that. Now the range, instead of going from 0 to infinity, it goes from 2 to infinity. And I should have a parenthesis on this one, okay, because the 2 is not included. Okay, so this should be a parenthesis here. Okay, and of course the horizontal asymptote is y equal to 2. Okay, so you have your domain, your range, horizontal asymptote, and the graph for that one. Let's clear this one. And then for the next one, we have the graph f of x equal to 1 over x to the x minus 2. Okay, so the base is less than 1, so this one then is going to pass. Normally this would pass to the point 0, 1, so it would come down like this, so it would go like this. Okay, so it would go like this, passing through 0, 1, so it would go through that point right there. Okay, but this x minus 2 shifts the graph over 2 units. Okay, so what we're going to do then is we're going to go over 2 units. So we'll go 2 units this way, and it's going to pass then through this point right here. Okay, so this would be the point. You can see if I put a 2 right there, 2 minus 2 is 0, 1 after the 0 power is 1, so this would be the point 2, 1. So the graph then is going to go something like this. Okay, so it's going to come down and approach the x-axis. So the horizontal asymptote is still going to be y equal to 0. Okay, the domain goes from 0 to infinity, and again this one needs parentheses. The 0 is not included, so there should be parentheses here, like that. The domain is still going to be the same. Okay, from minus infinity to infinity. Okay, clear this. Now let's look at the next 2 problems. Solve each equation. So these are exponential equations. Exponential equations are equations that involve or contain one or more exponentials. So this one has one exponential on the left and one on the right. Okay, so one technique for solving exponential equations is to try to get the base the same. If you cannot get the base the same, then this procedure is not going to work. You'll have to use logarithms, or you'll have to use a graphing calculator. But what I'm going to do here is I'm going to say, okay, on the left side I have a base of 2, so I want to try to write the right side with the same base. Well, I know that 4 is 2 to the second. Okay, so I'm going to write the 4 as 2 to the second, and then this would be x plus 1 here. Okay, then I'm just using laws of exponents. When you have a power to a power, you multiply the exponent. So you multiply 2 times the x plus 1. That means you multiply 2 times the x and 2 times the 1. So you get 2x plus 2. And then the property that I went over a while ago, if you have one that had a to the x equal to a to the y, if a to the x is equal to a to the y, the x and the y have to be equal. In other words, if the left side and the right side are equal and the bases are the same, then the powers on those bases have to be equal. So this would tell me then that 3x would have to equal to the power on the right side, which is 2x plus 2. Okay, now we just solve this linear equation. Add negative 2x to both sides. This cancels, and negative 2x and 3x gives me x. So I'm left with x equal to 2. Okay, that's the solution. Okay, now again, had this say, let's say this 2 to the 3x had been a 3 to the 3x, then there's no way I could have gotten these bases the same. So I'd have to use logarithms, like I said earlier, or use the graphing calculator. Okay, let's clear this. look at the next one. And this one I have e to the x squared is equal to e to the 3x minus 2. So here the bases are already the same. So all I know then is the exponents have to be equal. So the exponent on the left, which is x squared, has to equal to the exponent on the right, which is 3x minus 2. And then just a matter of solving this quadratic. So we take everything to one side. Okay, x squared, take the 3x over, becomes a minus 3x. Take the minus 2 over to the left, becomes a plus 2. And then the easiest way to solve a quadratic equation, a second degree equation, is factoring if it factors. If it doesn't, you can use quadratic formula or graphic calculator. This one easily factors into x minus 2 and x minus 1. Okay, you can check out the multiplication there. Okay, so we set each factor equal to 0 then, and we get that x has to be either 2 or 1. Okay, the next video will deal with logarithmic functions and so forth. And again, these are abbreviated lessons that we covered in college algebra at UTB. This would be equivalent to, say, chapter 2, so it'll be several lessons on this topic here. So we'll check you out in the next video, and please subscribe.